Hello, this is Mr. Wernick. I'm here to talk to you today about lesson 10.3, arcs and chords. Today we're going to be addressing arcs again. We're going to be talking about chords, but we're going to be talking about special relationships between the two. So we've already learned about chords. Chords are a line that connect one point on a circle to another point. And typically when we're talking about chords, we're talking about not a diameter, definitely not a radius, because a radius would connect the center to the outside at any point. But the diameter is, remember, a specific chord that goes through the center. So usually when we talk about chords, we're talking about ones that do not go through the center. We're looking at this theorem 10.2. If we have these same circle or congruent circles, two minor arcs are congruent if and only if the chords are congruent. So what we're talking about with the minor arcs, if we have AB here as this chord, this would also be arc AB. And we have arc XZ here that would come across like this. These arcs are going to be congruent if and only if this line across here is congruent to this line across here. XZ is congruent to AB as a chord. There's a proof for this, but very simply this is what happens. Anytime we have a radius, the radius is always exactly the same length. So what we have is two triangles that we could almost say, all right, these are side angle side, they're congruent, okay? But what happens is we have to be able to prove that those two chords are going to be the same length. And you can kind of take a look at how they did it on page 715. But basically, if we have these chords, it could happen anywhere. There can be any kind of relative distance close to what's going on here. Well, and we can't prove side angle side. We can prove sides together. But we need to be able to prove one other thing with this to try to get through there. And then be able to put those together as triangles, prove some kind of congruency there in that manner. And then we can say if those chords are congruent, then those two minor arcs are going to be congruent. The next one that we're going to take a look at is 10.3, and it groups together with 10.4. They're kind of inverse of one another. On 10.3, if a diameter or radius is perpendicular to a chord, it will bisect that chord and the arc. So if I have this right here, this circle, and you'll have to excuse my terrible drawing, but if I have a diameter that comes through here, and I can say that this is 90 degrees, I have drawn this perpendicular, then it bisects both this chord and this arc. So the arc is going to be in two separate equal parts, and that chord is going to be in two separate parts. Now 10.4 looks at it the other way. If I have this arc and this chord, and I draw something that is going to be perpendicular, in other words, I measure this out, and I use my compasses and come across, draw that line through there that goes through the middle, and I come up with that perpendicular bisector, it will be a diameter, and from that I can find the radius. So a radius or diameter going through the center of this, if it's a perpendicular bisector of the chord or the arc, specifically the chord on 10.4, if it's a perpendicular bisector of that chord, then it is a diameter. On the first one, the 10.3, if it is a diameter and it's perpendicular to that chord, then it's going to bisect. The next one that we have, the next theorem that we're going to look at is 10.5. If we have the same circle or congruent circles, chords are congruent if and only if they are equidistant from the center. So what I'm basically saying is if I have this that is 3 centimeters and I have this one over here that is 3 centimeters, if I draw a chord that is 3 centimeters away from center that way, and I draw a chord that is 3 centimeters away from center that way, then those two chords are going to be congruent because they are equal distances from the center. Now you'll have to be very careful with that one. It'll have to be perpendicular to make sure that it doesn't just go through a point that's 3 centimeters away from center, that the distance there is 3 centimeters instead. So it'll also kind of have to be perpendicular there from the center. But if they are equidistant from that center, they are going to be equal. Most of what you are going to be calculating today, and most of the math that you are going to do, is going to be focused around proving that these are congruent because the chords are congruent, so the arcs are congruent. If you get the arcs congruent, the chords are going to be congruent. You'll find X or something like that. On 10.3, 10.4, it'll be either proving that it's a 90-degree angle, so it bisects it, or saying this is a 90-degree angle. Find each part knowing that we bisected it. And on 10.5 here again, finding the distance, being able to say, okay, they're equidistant, which means they should be congruent, and we should be able to calculate their congruency, calculate any kind of variable that will be put into that place. Make sure you add these to the notes, 10.2, 10.3, 10.4, 10.5. This is going to be a pretty involved test that's going to have a lot of different properties that you're going to have to remember for it. If you have questions over some of this stuff, you're not real sure, you took a look at the proof on 10.2 and you didn't really understand how they prove those two congruent, come in, ask about that, show up to tutorials, or have your question ready for class, and we will address it then. We'll see you then.